Okay, so today we're really looking at complex conjugation. So suppose we've got x equals 3 plus root 2 and x uppercase star 3 equals 3 minus root 2. So the conjugation is 3 minus root 2. So what happens when we add them together? Well, 3 plus 3 gets us 6, and root 2 and negative root 2 cancels out, so we're left with 6. What happens when we multiply them? Well, 3 plus root 2 and 3 minus root 2, you're going to get 9, and then 3 multiplied by minus root 2, add 3 times positive root 2 will cancel out, and then it'd be 9 add minus 2, left with 7. Right, what do we notice? Well, they're both rational instead of 3. And this is particularly useful. So when we're looking at dividing by some sort of complex numbers, we can essentially rationalize it, but in this case we're going to get a real number out of it. So let's look at two examples. So we've got two complex numbers that are similar with this conjugation, 3 plus 2i and 3 minus 2i. Well, when we add them, 3 plus 3 is 9, and 2i and negative 2i will cancel out. And when we multiply them together, you get 9, 3 times 3. 3 times minus 2i is minus 6i. 2i times 3 is plus 6i, so you'll notice they will cancel out. And 2i times negative 2i, you get minus 4i squared. 4 times I squared, well, negative 4 times I squared is minus 4 times minus 1, so plus 4, and you're left with 13. So what do we notice here? Well, again, they're both real. So this is how we would essentially we could realize our denominator very similar to GCSE, when we can rationalize the denominator. In this case, we can do it with complex numbers. So let's look at an example. So in this case, Z would be A plus BI, and the conjugate of that would be A minus BI. So here's an example. Write 5 plus 4i over 2 minus 3i in the form A plus BI. So this is where we're going to essentially rationalize it, but in this case, realize it. So we're going to times it by 2 plus 3i over 2 plus 3i. So on the numerator, we're going to get 10 plus 15i plus 8i plus 12i squared. And on my denominator, we're going to get 4 minus 9i squared. When we multiply that out, that's going to leave us with 10, and we're going to take away 12. We're going to get 23i. So 23i, take away 2, all over 4. Well, minus 9 times minus 1 is positive 9. So 4 plus 9 is 13. And we want it in the form A plus BI. So we're left with minus 2 over 13 plus 23 over 13i. And there's our answer there. So a helpful tip. This is very similar to rationalizing denominators and surds. Helpful tip is A plus BI multiply A minus BI. You're left with A squared plus B squared. So very similar to difference of squares. You get A squared minus ABI plus ABI, they will cancel out. And the last part, minus B squared, I squared. And I squared is negative 1. So negative 1 times minus B squared is plus B squared. Okay. So pause the video here, and you can test your understanding. And I will now show you the answer. So, given that said 1 equals 3 plus 2i, and said 2 equals 12 minus 5i, all over said 1, can you find said 2 in the form a plus ib? Okay. So said 2 is 12 minus 5i all over said 1, which is 3 plus 2i. We're going to multiply that by the conjugate. So on my numerator, 12 by 3 is 36. 12 times minus 2i is minus 24i. Minus 5i times 3 is minus 15i. And minus 5i times minus 2i, well, you'll get positive 10i squared. Come back to that. And on the denominator, 3 by 3 is 9. 3 times minus 2i, and then 2i times 3 will cancel each other out. And then 2i times minus 2i is minus 4i squared. So let's clean this up. 36 plus, well, 10i squared becomes minus 10, so that becomes 26. Minus 24i, minus 15i, should collect on like terms here. And then minus 4 times minus 1, it comes positive 4, so 9 plus 4 is 13. And this will clean ourselves up. 26 over 13 becomes 2. 39 over 13 becomes 3. And there's your final answer. Done. So hopefully we all got that. Okay. Right, so now this is the part where you look at exercise 1D. And I will show an extension problem here. So you can stop the video now and finish the lesson. If you want to try the extension problem, you can pause the screen now and have a go at it. And I will now complete it. So, said equals x plus iy. X is an element of any real number. Y is an element of any real number. Find the value of x and the value of y. So let's start. 3 minus I times the conjugate of said plus 2i said equals 9 minus I. Okay. Well, the conjugate is x minus iy. So 3 minus I times x minus iy plus 2i said equals 9 minus I. Okay. I'm going to zoom in here. So my initial thinking here is I'm going to replace the said with x plus iy. So let's have a look. Okay, so what I'm going to do, I'm going to multiply out these brackets, and I'm going to get the following: 3x minus 3iy minus ix, and then I'm going to get minus I times minus iy. That'll leave me with positive I squared y. Positive I squared is negative 1. So I'm just left with negative y. Okay. Plus 2ix. And now again, 2i times I is I squared. That becomes minus 2. So minus 2y. That equals 9 minus I. Okay. So now we want to sort of group up our complex numbers and our real numbers. So our real numbers would be, well, if we got 3x minus y minus 2y. So that becomes 3x minus 3y. That's our real number. And we're going to plus, we've got minus 3iy minus ix plus 2ix. Okay. So the minus I plus 2i, it just becomes I. It's just like 1i. And we're left with this minus 3iy. So I can clean it up with minus 3y plus, we've got that 1x times by I. That equals 9 minus I. So now we've got some simultaneous equations. So we've got the real version here equals 9. And the imaginary version equals, well, we've got it as minus 1. So I'm going to rewrite that as the following. So 3x minus 3y, that gets me 9. And then I can see I can divide that all by 3. So let the following there. And then I've also got minus 3y plus x. That represents here minus 1. We can see that here. So we've got that as minus 1. Get some more space. So we've got some simultaneous equations here and here. I'm going to write them underneath each other. So minus y plus x equals 3. I'm going to do this one, take away this one. So minus 3y minus y becomes minus 2y. X minus x is 0. Minus 1 minus 3 is minus 4. So y equals 2. And therefore, I'll just pick this one here because it's the closest. Minus 2 plus x equals 3. So x equals 5, and there you are. X is 5, y is 2, and we have completed the question. So if I go all the way back to the beginning, z equals, what did I say x was? X is 5, and y is 2, so 2i, and we're done there. And thank you for watching the video.